Hello there, my favorite chargers. Today we're going to talk about square root functions. Square root functions pretty much are called that because they have square roots in them. So let's get down to some details of what this means. Square root function, the A, first part, well, okay, here we go. F of x equals is the same as y, function notation, equals, and this is how it's going to look, A times the square root of x minus h plus k. So A is our variable in front, not variable, constant in front, and then the square root of x. X is always going to be under the radical, minus h. There may or may not be anything under the radical with x, but if there is, we call it h, and then plus k on the end. All of these parts of the function change the way that the square root function looks when it's graphed. So let's talk about what each of these constants does to our graph, and then we'll look at the graph and compare what it looks like when it changes. So A, the constant in front, changes the curve shape. It could make it steeper, flatter, just changes the way the curve looks. You'll see when we do some examples here in just a moment. A can also, when negative, causes a vertical reflection. So vertical reflection means that it's flipped over. If it starts out like this, pointing kind of up like half of a C, a negative A will flip your function upside down. Okay, next, let's look at H. H stands for horizontal shift. That means it moves along the x-axis in either direction. Finally, we have K, which causes a vertical shift. All right, so all of those parts have a different meaning when it comes to graphing these functions. We can totally do it. Don't despair. So steps to making a graph. Step one, make a table. Always make a table of values starting with the point HK. That's always going to be point number one when we make these graphs. Number two, calculate more ordered pairs for the table. And I'll show you how to do that really soon. Step number three, connect with a smooth curve. Last one, number four, find the domain and range. All right, those are the steps. Let's put those into action. We're given y equals square root of x. This is what's called the parent function. So this is mommy and daddy function that all of the other functions are made from. And when we compare, when we try and figure out how a function changes because of differences in the equation, we're going to always compare it to the parent function, y equals the square root of x. So let's rewrite it like the standard form above. So this will be f of x equals, a is 1, because there's nothing there, so we're going to assume it's 1, times x minus, well, we can see there's nothing here with x under the radical, so we make that a 0, plus k is 0. Ooh, that's the worst 0 in the history of zeros, plus k is 0. So we start x and y are h and k respectively. So h is 0, so x is 0. K is 0, so y is 0. Now, we want to think of the next perfect squares because we're going to take square roots. So we only want perfect squares. So the first 5 perfect squares are 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Okay, so those are the x values, only perfect squares that we're going to plug in here for x. The y value is just the square root, so just 1, 2, 3, 4, and 5. So now we can plot at least some of these points. We know we have 0, 0. We have 1, 1, 4, 2, 9, 3, and I think that's all we can fit. Now this is not a straight line, so let's see how this looks. Something like that. It's got a specific endpoint, and it'll go on forever after it goes through all the points that we've plotted. So the domain and range is the last part. It's going to be x for the domain and y for the range. It's only part of it, don't despair. The other part of the domain and range comes from the first 2 values in our table of values, that h and k. I'm going to write those down. H goes with x, y goes with k, and leave some space in the middle, because now we need to give everything a sign. I'm going to look at my table of values. My first value is 0, and then the next one is 1. Well, 1 is greater than 0, so the domain is greater than or equal to 0. Same direction with an equal to. For the y column, start at 0. Next value is 1. That's greater than, so our range is greater than or equal to. These are all going to be the same process. So if you can just work with me and figure this part out, you're going to be golden. Let's do some more examples. First, y equals square root of x, we're going to plot. That's always the same points. 0, 0. I didn't want to do that. 0, 0, 1, 1, 4, 2, 9, 3. Ish. So now let's plot y equals square root of x plus 5. Well, our h, there is nothing under the radical with x again, so h is 0. And k, we do have a k this time, and k is 5. Now, I want to look at the radical. There is nothing under the radical. Radical is another word for square root, by the way, if I didn't mention that. Nothing under the radical besides x. So my x values in the x column are going to be the perfect squares. 0, 1, 4, and 9. Now, when I plug those in to my equation, I don't get 1, 2, 3, and 4. I get the square root of 1 is 1 plus 5 is 6. Square root of 4 is 2 plus 5 is 7. Square root of 9 is 3 plus 5 is 8. Now, let's plot those points. 0, 1, 2, 3, 4, 5. 1, 6. 4, 7. 9, 8. So you can see the orange line of our new function, y equals square root of x plus 5, is different than the red function, the parent function, y equals the square root of x. Let's put the domain and range for our new functions here. The domain, remember, gets an x, range gets a y. Put the first 2 values in our table here, 0 and 5. We look at the x column, 1 is greater than 0. So our domain's greater than or equal to. If I look at the y column, 5 goes to 6, 6 greater than 5. So our range is greater than or equal to. Last part, transformation. You can refer to the front and show what the different values in our function mean, or you can just look at these two functions. And we see that once we have drawn the square root of x function, the orange one goes up. It's exactly the same function. We just scooted it up. When we scooted it, 1, 2, 3, 4, 5. So it went up 5 units. All right. All right, let's do another one. Whew. First, always, we're going to plot that parent function. 0, 0, 1, 1, 4, 2, 9, 3. Now, let's draw the new function. Y equals negative, or x minus 2, square root of x minus 2 minus 1. So if you look back on the first page, you'll see that the standard form here was y equals a square root of x minus h plus k. So our h is just going to be this number here with an opposite sign in front. So if this number is negative 2, our h is positive 2. The opposite goes for the k part. If k is negative 1, y is negative 1. It's super confusing, I know, but we'll do enough of these that you'll finally get used to it. So now, the x minus 2 under the radical gives us a little bitty baby bit of a problem going forward, because I'm going to scoot this over and do some more work over here on the side. We want what's under the radical to be a perfect square. So remember, our perfect squares are, besides 0, 1, 4, and 9. So I'm going to take what's under the radical and set it equal to each of those numbers. So when I solve x minus 2 equals 1, I add 2 here, add 2 here, I get x equals 3. That's my next value in my x column. Same goes for the x minus 2 equals 4. I solve for x, and I get x equals 6. It's my next value. Last one, add 2, and I get x is 11. So that fills out my x column. Now to find the y values for these, we just plug these numbers into our equation and solve for y. So I'm going to erase this and make some more room. So bear with me. All right. So for the first one, we'll have y equals the square root of 3 minus 2 minus 1. Well, 3 minus 2 is 1. Square root of 1 is 1. 1 minus 1 is 0. So when x is 3, y is 0. Then we can plug in 6. Square root of 6 minus 2 minus 1. Well, that's the square root of 4 minus 1, or 2 minus 1, or plain old 1. Last but not least, square root of 11 minus 2 minus 1. That's the square root of 9 minus 1, or 3 minus 1, or just 2. So here's what I want you to notice. When we solve for these crazy weird values that come out from underneath the radical, that makes it so that our y values increase by 1 all the time, as long as there's no a. Hint here, you're always safer to just plug it in. Let's plot these things. All right, we've got 2, negative 1 for our first point, 3, 0, 6, 1, and 11, 2. Looks something like that. Let's do the domain and range. The domain is X, range is Y. And we've got 2 and not 3, -1 that top our columns. We look at the X column, 2 goes to 3, goes up. So that's greater than or equal to. -1 goes to 0, that's increasing. So it's also greater than or equal to. Our transformation this time is twofold because we have both an H and a K value. So we can see that our function went right 2 units and it went down 1 unit. If we look at our equation, we can see that down or right 2 is this 2 in the H position, down 1 is -1 in the K position. All right. Moving on. Same idea here. We're going to plot y equals square root of x, 0, 0, 1, 1, 4, 2, 9, 3. Now, for our transformation function, we do h and k. H is -1 here, so it's +1 in the x column. K is +4 here, so it's +4 in the y column. Opposite sign, same sign. Now, there's some fun stuff underneath the radical with x. Again, of course. So let's figure out what it is that's supposed to be underneath the radical, what our perfect squares are. I've got x minus 1, and that equals 1. We're going to solve for that. X minus 1 is 4, and x minus 1 is 9. We can solve for x, add 1 to each side, and we get x is 2. It goes in the x column. Add 1 to each side, and we get x is 5. In the x column again. And add 1, and we get x is 10. Goes in the x column. I'm going to have to erase for 2 reasons. One, because I have no idea what that shape is. And 2, I've got to erase because now we need to find what y is. Make that a 2. So I plug in 2. We have negative square root of 2 minus 1 plus 4. It's negative square root of 1 plus 4, negative 1 plus 4, or 3. We have negative square root of 5 minus 1 plus 4. It's negative square root of 4 plus 4, or negative 2 plus 4, or 2. And last, we've got negative square root of 10 minus 1 plus 4, negative square root of 9 plus 4, negative 3 plus 4, or 1. All right, so now we plot these points. We have 1, 1, 2, 3, 4, 2, 3, 5, 2, and 10, 1. Looks a little something like that. It's the best one yet that I've drawn. Hooray for me. Our domain, x and y. First 2 numbers in our columns. Let's check out how they change. X goes from 1 to 2. That's going up, so that's greater than or equal. Y goes from 4 to 3. That's down. So that means instead of going up, and greater than, it's less than or equal. We've got 3 changes this time because we have an A, an H, and a K. Our transformation is it's gone right 1 unit. It's gone up 4 units. And it's been reflected vertically. I can get those all off of the very front page where I told you what all the parts meant. If you can't see it on the graph and understand what it means, just read it off that chart on the front. One more and then we're calling it quits. All right. Y equals square root of x. Let's do that one first. 0, 0, 1, 1, 4, 2, 9, 3. Let's do this. All right, put H and K in our table. K, there is no K, H, so we make it 0. K is 3. Nothing under the radical but x, so we use those first 3 perfect squares. And then we plug them in. 2 times the square root of 1 plus 3 is just 2 times 1 plus 3, or 2 plus 3. What's that 2 doing? Or 5. And then we've got 4 times the square root of 1 plus 3. And that's just 4. Oh, crap. I did that all wrong. I am super sorry. Lost it. 2 times the square root of 4 plus 3. That's 2 times 2 plus 3, or 4 plus 3, or 7. Last but not least, 2 times the square root of 9 plus 3, or 2 times 3 plus 3, or 6 plus 3, or 9. Let's plot this baby. All right, we start at 0, 3, 1, 5, 4, 7, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plot that curve. That looks a little bit different, huh? Our domain, again, x and y. X and y values, 0 and 3. Look at the x column. We go from 0 to 1. That's increasing, so it's greater than or equal to. We look at y column. From 3 to 5 is increasing, also greater than or equal to. Our transformation will be a couple of different things. It'll be that we've gone up 3 units and we've stretched vertically. That means that instead of being this slow arching curve, it gets steeper faster. I hope this all makes sense. I know it's a lot all at one time. I know it's a long video and I'm sorry about that. Please let me know if I can help or if you have any questions, and I will look forward to seeing you soon.